Geothermal energy. The mystery about the shape and size of the Earth is nothing compared to the mystery of what lies inside it. One such mystery is known as geothermal energy, which is the heat that lies within the Earth. This heat energy is obtained from hot rocks present inside the Earth. The word geothermal comes from the Greek words geo or earth and therm or heat. This renewable energy source constantly produces heat inside the Earth, thus making it inexhaustible to mankind. Almost 4,000 miles beneath the Earth's surface, this phenomenon known as geothermal energy gets generated deep inside the Earth's core. The outer core is made up of very hot magma or melted rock surrounding a solid iron center, which is the inner core. Slow decay of radioactive particles continuously produces very high temperatures inside the Earth. This process is natural in all rocks. Surrounding the outer core is the mantle. About 1,800 miles thick, it is made of magma and rock. The outermost layer of the Earth is the crust. It forms the continents and ocean floors, running 3 to 5 miles thick under the oceans and 15 to 35 miles thick on the continents. The Earth's crust is broken into several pieces called plates. Magma comes close to the Earth's surface near the edges of these plates. These are the places where volcanoes occur. The lava that erupts from volcanoes is partly magma. Deep underground, the rocks and water absorb the heat from this magma. The temperature of the underground rocks and water increases with increasing depth. People around the world use this underground energy to heat their homes and to produce electricity by digging deep wells and pumping the hot underground water or steam to the surface. Since ancient times, geothermal energy has been used for heating as well as bathing. Even today, hot springs are used worldwide for bathing. Using geothermal energy to produce electricity is a relatively new industry which came into existence in 1904. The Italians first used the natural steam erupting from the earth to power a turbine generator. The first successful American geothermal plant began operating in 1960 at the Geysers in Northern California. Most of American geothermal power plants are in California, with the remaining in Nevada, Hawaii, Idaho, Montana, and Utah. Naturally occurring large areas of hydrothermal resources are called geothermal reservoirs. Most geothermal reservoirs are deep underground, with no visible clues showing above the ground. Geologists use different methods to find geothermal reservoirs. The only way to be sure there's a reservoir is to drill a well and test the temperature deep underground. Geothermal energy sometimes finds its way to the surface in the form of volcanoes and fumaroles. Fumaroles are holes where volcanic gases are released. It also manifests itself in the form of hot springs and geysers. Active geothermal resources are usually found along major plate boundaries where earthquakes and volcanoes are concentrated. Most geothermal activities in the world occur along the borders of the Pacific Ocean, called the Ring of Fire. When magma comes close to the Earth's surface, it heats groundwater trapped in porous rocks or water running along fractured rock surfaces and faults. The heat energy produced, mainly using water or hydro, and heat or thermal, is called hydrothermal energy. Even though there is more than one type of geothermal energy, this is the only one widely used. Some applications of geothermal energy use the Earth's temperatures near the surface, while others require drilling miles into the Earth. Depending on the temperature of the hydrothermal resource, the heat energy can be used for heating, making electricity, or as heat pumps. Ancient Romans, Chinese, and Native American cultures used hot mineral springs for bathing, cooking, and heating. Even today, many hot springs are still used for bathing for its natural healing powers. Hot water from springs or reservoirs near the surface is used for heating buildings. Hot water near the Earth's surface is piped directly into buildings and industries for heating purposes. Industries use geothermal energy for food dehydration, gold mining, milk pasteurization, and growing crops. Hydrothermal resources at high temperatures, 300 to 700 degrees Fahrenheit, can be used to make electricity. Either from dry steam wells or hot water wells, they can be used by drilling wells into the earth and piping the steam or hot water to the surface. Geothermal wells are 1 to 2 miles deep. Geothermal heat pumps use stable ground or water temperatures that hold nearly constant between 50 degrees and 60 degrees Fahrenheit throughout the year near the Earth's surface to control building temperatures above the ground. They transfer heat from the ground or water into buildings in winter and reverse the process in the summer. Unlike solar, wind, or tidal energy, geothermal energy can operate round the clock. This source of energy is free and renewable. Geothermal energy is virtually pollution-free and does little damage to the environment. Geothermal plants produce virtually no emissions because they do not burn fuel to generate electricity. Its operating cost is also quite low. Another advantage is that geothermal plants don't have to transport fuel like most power plants. Geothermal plants sit on top of their fuel source. Geothermal power plants have been built in deserts, in the middle of crops, and in mountain forests. Not all areas are suitable for production of electricity with the help of geothermal energy, and it also depends on the structure of rocks. The generation of geothermal energy creates noise pollution and releases noxious smells. Even though its operating costs are low, cost of setting up a geothermal plant is very high. Also, it is expensive to drill holes so deep into the earth. In some places such as Iceland, hot water comes naturally to the surfaces as steam, which can drive turbines to generate electricity. Some power stations make use of lava that flows from the volcanoes. In India, there are about 400 hot springs that can be tapped for geothermal energy. Even though Ladakh, Gujarat and Madhya Pradesh have good geothermal energy potential, no plants have yet been set up. Despite a few disadvantages, it is an undeniable fact that geothermal energy is an extremely valuable, simple and clean source of energy that can benefit mankind in a big way.
Nuclear energy facilities generate carbon-free electricity in 30 countries around the world. Nuclear energy production is similar to the ways fossil-fueled power plants generate electricity. A nuclear energy facility provides clean, safe electricity 24 hours a day. Let's go inside the plant to find out how. In most generating plants, whether coal, nuclear, or natural gas, some form of energy is used to heat water into steam. This steam turns a turbine that is coupled to an electromagnet called a generator. The generator produces electricity. While the model is the same, there is a key difference between nuclear energy facilities and other electricity generating plants. Power plants that run on fossil fuels burn coal, oil, or natural gas to generate the heat that creates steam. In a nuclear energy facility, a chain reaction of splitting atoms releases heat. This reaction takes place in the reactor. All reactors are designed, built, and operated with safety as a top priority. Nuclear energy facilities are among the safest facilities in the world because they feature multiple redundant layers of safety systems and procedures, beginning in the core of the reactor. In a nuclear reactor, metal rods with enriched uranium pellets inside are placed into bundles, creating a fuel assembly. The bundles are submerged in water inside a pressurized vessel. The two most common types of nuclear reactors are boiling water reactors and pressurized water reactors. In a boiling water reactor, the heat from split atoms causes the water to boil, producing steam that drives a turbine. Afterwards, the steam is converted back to liquid water and returned to the reactor core. Pressurized water reactors, or PWRs, were developed after boiling water reactors and work in a slightly different manner. In a PWR, the water in the reactor tank is under pressure to keep it from boiling, even though it reaches very high temperatures. In the steam generator of a PWR, water passes through thousands of small pipes. The heat in the pipes turns the water to steam, which then drives the turbine. The turbine powers the generator, which in turn produces electricity. Here is where the process differs from a boiling water reactor. The reactor water is now pumped back into the reactor tank and heated again. The steam from the turbine is cooled in a condenser, and the resulting water is sent back into the steam generator and heated again. To prevent overheating, control rods made of a material that absorbs small atomic particles are inserted into the nuclear fuel bundle. When an operator wants to produce more heat, the control rods are raised out of the bundle. To create less heat, they are lowered into the bundle. The rods can also be lowered completely to shut the reactor down in the case of an accident or to refuel the facility. With this level of control, the operator of a nuclear energy facility is able to ensure that it continues to generate clean, safe, and secure energy. Additional safety systems are in place that shut the reactor down quickly and stop the fission process, cool the reactor down and carry heat away from it, and create barriers to contain any radioactivity and prevent it from escaping into the environment.
The water of the oceans of the world is almost always in motion. Hardly ever interrupted, waves break at the coastlines, sometimes strong, sometimes weaker. There is an enormous energy potential that is available round the clock and free of charge. A potential that, if fully exploited, could satisfy 40% of the worldwide demand for power. This equals the output of 700 to 800 nuclear power stations. Voigt Hydro Wave Gen is developing technologies to convert this inexhaustible energy into electric power without the emission of harmful greenhouse gases. The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine, named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy. This is how easily energy can be generated with a wave power station, day and night, all year round, as long as there are waves. The world's first power station of this kind was put in service as early as November 2000 on the Scottish island of Islay and has been feeding power to the grid ever since. Voigt Hydro Wave Gen is convinced of the commercial potential of wave energy. We are certain that our wave power stations can make a significant contribution to supplying the world with climate-friendly energy. Voigt, engineered reliability.
Twice a day, and every day since the world began, the oceans produce powerful water currents and tidal movements that are so reliable they can be predicted years in advance. For centuries, mankind has sought to exploit this massive source of potential energy. In Roman times and the Middle Ages, mill wheels driven by flowing water were used extensively for grinding wheat into flour. Until recently, there has been little development in our ability to harness this huge resource of power. Today, the wonders of modern technology have allowed us to extract this huge potential of raw energy for the production of electricity without harming the environment. So why the focus on tidal energy? The world has an increasing insatiable appetite for power. Global warming is compelling us to move away from fossil fuel and other high-risk fuels to clean, green, renewable sources. What are the advantages of tidal energy? It's renewable and sustainable. Seawater is 832 times denser than air, which means an 8-knot tidal current has more energy than a 380 km/h wind. Once a turbine is installed, tidal energy is free. No expensive fuel is required. It has a very low maintenance cost. Tides are predictable many years in advance. There is no impact on the visual amenity as tidal turbine is underwater. It is the most energy dense of any renewable energy source. It produces energy for the lowest cost. According to international environmental expert Dr. David Suzuki, tidal energy has one of the smallest footprints of any renewable energy resource. Experts estimate there is over a staggering 59 terawatts of power available through tidal energy in the United Kingdom alone that remains unutilised. What makes tidal energy different to its competitors? Whilst most companies have been working on new versions of the mill wheel or windmill technology, tidal energy took a different approach, working on turbines mounted in shrouds, also known as venturis, to increase turbine efficiency. In doing this, tidal energy has developed a unique system called the Davidson Hill Venturi turbine that is able to generate electricity from almost any form of moving water. The Davidson Hill Venturi turbine established a world benchmark in 2003 for the highest efficiency ever produced from a water turbine. The unique Davidson Hill turbine achieves the marine equivalent of breaking the sound barrier. Griffith University in Australia and industry experts have independently tested the Davidson Hill Venturi turbine, declaring it the most efficient water turbine technology ever. They also proved the scalability of the design, allowing Tidal Energy to develop a range of Venturi turbines in sizes from 2.25 metres squared to 100 metres squared, capable of generating power from a few kilowatts to megawatts. The Davidson Hill Venturi turbines can be scaled or arrayed to suit almost any need, from remote settlements to small cities. The electricity produced can be fed directly into the grid or used to offset the cost of existing power generation.
Wind energy. Air in motion possesses kinetic energy, and this energy is trapped as the wind energy. Wind energy is one of the first sources of energy known to man. It has been tapped by humans for thousands of years for several uses. Wind is produced by the uneven heating of the Earth's surface by the sun. Since the Earth's surface is made of various land and water formations, it absorbs the sun's radiation unevenly. When the sun is shining during the day, the air over land masses heats up more quickly than the air over water. The warm air over the land expands and rises, and the heavier, cooler air over water moves in to take its place, creating local winds. Similarly, the large atmospheric winds that circle the Earth are created because the surface air near the equator is warmed more by the sun than the air over the north and south poles. Wind is called a renewable energy source because wind will continually be produced as long as the sun shines on the Earth. Whether it is winnowing to remove husks from grains in the early age, or propelling sailboats in rivers and seas, or manufacturing products, or, in modern age, to generate electricity, wind has been used to the optimum. In modern days, the most common use of wind energy is to generate electricity, for which wind turbines or windmills are used. Often built in open spaces and fields called wind farms, they provide a portion of the world's energy. Like old-fashioned windmills, today's wind machines, also called wind turbines, use blades to collect the wind's kinetic energy. These blades are connected to a drive shaft of the wind turbine. So, when the blowing wind strikes across the blades of a windmill, the exerted force causes the blades of the windmill to rotate, which in turn rotates the shaft of the turbine and generates electricity. Apart from generating electricity for homes and industry, windmills are used for cutting wood at sawmills and in water lifting pumps with an electric generator. Small wind turbines, called aerogenerators, are used to charge large batteries. In some areas, windmills are also used for grinding grain and pumping water. Being completely dependent on wind, it poses a problem when the wind is not blowing. At those times, other types of power plants must be used to make electricity. From time immemorial, wind energy has been used to propel a boat. A large sheet of canvas, called the sail, is used in such a way that the wind falls on it. In a single sail, if the wind is not blowing in the desired direction, the sail becomes useless. Hence, two sails are used, one to divert the wind and the other to collect this diverted wind. Also used for flying aeroplanes and gliders, wind gives the necessary upward lift to keep an aircraft afloat, while a glider depends on the wind energy for its flight. The pilot can manipulate the special surfaces on the wings of the planes to change the way air flows around it, thereby controlling the lifts and the altitude of the plane. Depending on wind for energy has its own set of advantages and disadvantages. The first advantage of wind energy is that it is available everywhere and in plenty. This renewable source of energy can never be depleted. Wind is a clean source of energy and has fewer environmental impacts. Unlike other power plants, wind turbines do not release emissions that pollute the air or water, and they do not require water for cooling. It is a great alternative to fossil fuels. Shortage in oil and natural gases has led to wind power becoming highly desirable. In many countries, wind energy is an economical power resource, and as there is no fuel input, it is one of the lowest priced renewable energy technologies available today. However, wind energy also has several disadvantages. Even though wind energy is available in plenty, wind is not available at all times. It can be unpredictable and unreliable. The sound made by the wind turbine blades can be annoying, and some types of wind turbines and wind projects cause bird and bat deaths. Good wind sites are often located in remote locations, far from cities, where the electricity is needed. Transmission lines must be built to bring the electricity from the wind farm to the city, so that the conservation of non-renewable resources will also occur in urban areas, where there is maximum consumption of energy. Wind turbines generally produce a lot less electricity than the average fossil-fueled power station. Hence, multiple wind turbines need to be built, which is expensive and time-consuming. Man has realized the growing importance of wind energy. In the wake of oil shortages, wind power has made a comeback. New technology is still being invented to make even further use of this ancient power source. 5 nations, Germany, USA, Denmark, Spain and India, account for 80% of the world's installed wind energy capacity, and it continues to be the fastest growing renewable energy source.
Solar energy. Did you know that sunlight is the Earth's primary source of energy? The sun is a seemingly inexhaustible source of energy. Although just a tiny fraction of the sun's energy hits the Earth, it provides enough energy in 1 minute to supply the world's energy needs for 1 year. This energy is the result of nuclear reactions taking place within the core of the sun. The source of the sun's fuel is hydrogen and helium gases. Through a special chemical reaction called nuclear fusion, the hydrogen gas is burnt, releasing an enormous amount of energy in the form of light and heat. Thus, energy obtained from the sun is known as solar energy. It is a renewable and non-polluting source of energy. Solar energy is most readily available and free. Energy from the sun travels in the form of electromagnetic waves. Solar energy is harnessed naturally by plants in the form of photosynthesis and artificially by humans with the help of many solar devices which are used for various purposes like cooking, heating, generation of electricity, etc. Let us study these solar devices in detail. A solar cooker is a device which uses the energy of sunlight to cook food. The basic principle for solar cooking is converting sunlight to heat energy that is retained for cooking. Though solar cooking is slow, the food is more nutritious and tastier. A box-type solar cooker is made up of insulated metal box, painted black from inside, attached with a plain mirror that acts as a reflector and a thick glass sheet cover to trap the heat in the box. The food to be cooked is kept in black containers inside the box. Position of the cooker is so adjusted that the sunbeam falls directly on the reflector, and from there it reflects on food containers. As the temperature inside the box rises, the food gets cooked slowly. In a parabolic solar cooker, the reflector is concave or parabolic. Solar water heater is a device to heat water using solar energy and normally installed on the roof. It consists of solar panels called collectors fitted to the roof. These collect heat from the sun and use it to warm water which is stored in well-insulated tanks. A solar water heater works on the basic principle that hot water has lesser density than cold water and hence it rises. As the water heats up, it rises in the pipes. Every time hot water is used from the top, more cold water enters the tube for heating. A solar cell, also known as a photovoltaic cell, is a device that absorbs sunlight and transforms it into electricity by way of the photovoltaic effect. It is based on a simple principle that electricity is produced when sunlight falls on certain semiconductors like silicon, selenium and gallium. These materials exhibit a property known as the photoelectric effect that causes them to absorb photons of light and release electrons which form an electric current. The photoelectric effect was first noted by a French physicist, Edmond Becquerel, in 1839, and the first solar cell was developed in 1954. Many small solar cells can be joined in a definite arrangement called solar cell panels to produce a large quantity of electricity. The DC or AC inverter of a solar panel array converts the low voltage direct currents DC from the cells to high voltage alternating current AC required by most household appliances. A solar vehicle is an electric vehicle powered by solar energy. It requires hundreds of photovoltaic cells in a solar array that convert sunlight directly into electricity to run. The solar arrays are most commonly mounted onto the vehicle in a horizontal or vertical position to collect sunlight. Solar energy enjoys many environmental and economic advantages over other forms of energy currently used. Solar energy is a non-polluting and a reliable source of energy. It is a limitless resource that can be collected without the environmentally destructive processes of mining or pipelines. Scientists estimate that our sun will continue producing solar energy for another 5 billion years. This makes it the ultimate renewable energy available to us. Solar devices used to capture the solar energy require very low maintenance. Solar energy is very helpful for remote areas that are not connected to energy grids. In some poorer countries where people have used kerosene and candles for domestic heating and lighting, respiratory diseases and impaired eyesight have resulted. Many people have been burned through accidents involving kerosene heating. Solar energy, especially with excess energy stored for nighttime use, overcomes these problems. One of the main disadvantages is the initial cost of the equipment used to harness the sun's energy, although the cost is coming down as technology improves. Solar panels and solar lighting may seem quite expensive when you first purchase it, but in the long run it is extremely cost-effective and requires very less maintenance. Also, solar energy is only useful when the sun is shining. During the night or overcast days, power will be produced at a reduced rate. However, the use of solar battery chargers can help to reduce the effects of this disadvantage. Thus, solar energy is the most promising alternative energy resource for our future.